So today with me, my colleague SK is here, and he is from the chemical engineering background. He has done his masters from one of the India's leading institute, IIT Guwahati, and now currently he is pursuing his PhD in the chemical engineering itself. The PhD topic he is working on is controllers based on the AI and other chemical engineering subjects which he is good at is something like a mass transfer, heat transfer, numerical methods, process control, and the mathematical modeling basically. So he is a core chemical person and he is with us today and then he wanted to guide on these topics to the students. So let's, without any delay, let's discuss with the SK. Hello, SK. Hi, how are you?
Hi Suraj, great, I'm fine.
Okay, that sounds good. Regarding the chemical engineering, overall chemical engineering, what exactly you can guide to the students? What are the key subjects and that things basically?
Hmm. So chemical engineering basically deals with the modeling part. So basically, chemical reactors they have to design the chemical reactors. If you come to mass transfer, so
Mm-hmm.
there are subjects like distillation. There are subjects like gas liquid operations and all. So students has to have a knowledge how to what is the basic things happening there. What are the primary things happening in the molecular level, and then they have to scale that up.
Mm-hmm. Okay.
So students in the chemical engineering basically designing the reactors. They are basically designing the distillation columns, all the chemical setup. So all the
Mm-hmm.
design principles, whatever they have.
Mm-hmm.
So the fundamental principles like mass balance, energy balance. So they
Mm-hmm.
have to they will teach these kind of things in chemical engineering. So that they
Okay.
can design the chemical equipment. So for that, for the fundamental principles part, students
Mhm.
has to learn mass transfer. Students
Okay.
has to learn heat transfer, and
Mm-hmm.
and for the calculation part, student has to have a good understanding of numerical methods. So basically,
Okay.
numerical methods is about differentiation and integration, right? So in the integration, there are sometimes we don't get an analytical solutions for the integration and differential equations. So there
Mm-hmm.
are so many techniques in numerical methods. So
Mm-hmm.
and there are so many packages also available. Like students has to be aware of all these techniques so that
Mm-hmm.
when they become engineers finally, they can apply
Mm-hmm.
all these things.
Mm-hmm.
And coming to the process control, as you all know
Mm-hmm.
that it's backbone of the industry because process control deals with the automation.
Mm-hmm.
Yeah, so if you look at the current industry scenario, everybody is going for automation.
Mm-hmm.
And in the future, they're saying that most of the AI will take over the world.
Mm-hmm.
So why I choose process control is I just
Mm-hmm.
want to be a pioneering engineer in the AI based controllers because automation is very interesting
Mm-hmm.
and there are very few people who are doing process control who are doing PhD in process control.
Okay.
Yeah, it is a bit tricky subject actually. Process control is a bit
Mm-hmm.
tricky subject, but if you
Okay.
understand it, if
Mm-hmm.
you really work in it, you can really
Mm-hmm.
enjoy it, and you can also have various opportunities in process control.
Okay. Okay.
So
Understood. Understood.
students who are pursuing chemical engineering has to have definitely should have a good understanding of process control also.
Mm-hmm. Okay, okay. Understood. So thank you, SK, for giving the brief introduction about what students should focus on in the chemical engineering and what it
Hmm.
is all about. Like as you have mentioned, you are doing your PhD in the controllers based on the AI, right?
Yes, yes.
Yeah, so can you give some idea about that in more detail? What exactly is that, and then what are the key topics in that, or what you are studying into it in the particular?
Hmm.
So that perspective will be definitely helpful, basically, to the
Okay,
student.
so if you coming. come to process control, for the students, they have to learn MATLAB actually. The there is some tools called Simulink. It will be very helpful to visualize what's happening in the system. And coming to the my project, PhD project, there are I'm working on the AI based controllers, right? So basically, it's an identification. We every system has an inputs and outputs, right? Every system has input and output, and I design an artificial intelligence model which train based on that input and output of the model, and which will mimic that model, which real whether it is a real life model or mathematical model. So this artificial intelligence model will help us to gain insights about the real life model. So so for the students part, i just I just tell them to learn Python, basically for the data analysis, because see, nowadays data analysis is entering every field, like if you take biotechnology, mechanical engineering, civil engineering.
Mhm.
So especially for chemical engineers, if
Mhm.
I really urge students to learn data analysis.
Okay.
Even
Okay.
in the research, if you go into the research for anything like molecular dynamics or any part,
Mhm.
the people
Mhm.
will ask you to analyze the result, people will ask you to analyze the data.
Mhm. Mhm.
So if
Okay.
you if you learn the data analysis methods, it will be
Mhm.
really helpful in the student's life. It will be really helpful for the career.
Okay.
Yeah.
Okay. Understood. Understood. So, yes, okay, basically in the process control, you are putting it like with the AI and with the data analysis, and you are telling the student data analysis is very key, and
Hmm.
it is more used in the domain of process control and any other domains also.
Yes,
And
yes,
but
yes.
students should focus on the Python, right?
Yeah, Python is a language. The Python, if
Okay.
you learn Python, you can just use data analysis modules easily.
Mm-hmm.
But at the core level, very basic level, there it is completely full of mathematics.
Mathematics. Okay. Okay. So,
Mathematics like
what kind of mathematical models you mentioned? Like you're mostly working on the mathematical models. So, can you give some depth idea about these mathematical models, numerical methods, basically, in detail?
so if you come to the data analysis, so
Mm-hmm.
the mathematics you should deal something like linear regression,
Mm-hmm.
extrapolation, interpolation, these kind of things. And
Mm-hmm.
this is all comes into the machine learning part. If you
Mm-hmm.
go something deep, next level is deep learning.
Mm-hmm.
If you go to the deep learning, you will get artificial neural networks. So
Mm-hmm.
this is a bit advanced concepts,
Mm-hmm.
but the students at least have to have an understanding of all the basic. I'm not telling you to learn the advanced things, but every student must have understanding of basic concepts like linear regression, interpolation, extrapolation, which will be
Mm-hmm.
used in every field in the engineering.
Correct. Correct.
And
Correct.
coming to the process control, so the
Uh-huh.
mathematical models we deal
Mm-hmm.
are actually differential equations.
Okay.
So we deal with the simultaneous differential equations. If you go to the industry, if you go to the, let's say if you just look at the satellite, the
Mm-hmm.
satellite has so many parameters. It has the position variables, it has the thrust variables. So all these variables are written in the form of differential equations,
Mm-hmm.
and you will be working on solving those differential equations. How can you solve this differential equation? And you have a desired path. You for like, let's say a chemical reactor, you're trying to cook a component, you are trying to cook some mixture, or you are trying to cook some catalyst,
Mm-hmm.
you prepare some new substance. So your desired value, your desired composition, to reach that, you just have to control all the process variables, right? So how these process variables are dependent on the output, basically they are written in terms of differential equations. So students have to be have a good understanding of solving these differential equations. And in industry also, if you go to the industry, if you have a good understanding of mathematics, basically if you know the principles, if you know the basic principles, mass balance, energy balance. These are very important in the industry because wherever you go, they keep asking. You have to keep coming back to these basic principles. Whether
Mm-hmm.
you just see a chilling tower in a chemical industry, or if you see a
Mm-hmm.
distillation column, or if you see a heat exchanger,
Mm-hmm.
or if you see a valve, if you see some pressure valve, or any instruments, you just the supervisor of the industry or the manager in the industry will come and ask you what are the basic
Mm-hmm.
principles this instrument is running on.
Okay,
So
okay, understood.
yeah, so if the students have basic understanding of mathematics, basic
Mm-hmm.
understanding of fundamental principles,
Mm-hmm.
yeah, they can understand, they can build their career, they can understanding any equipment in the industry.
Okay, okay, understood. So basically, for any process control engineer, mathematical models are very important, and
Yes,
differential
yes,
equation is one of the backbone of that,
yes,
basically.
yes.
Okay, okay, understood, understood. Thank you very much, SK, for the in-depth information about the process controllers. So now going ahead with the mass transfer and the heat transfer, basically. So how exactly that matters in terms of chemical engineering? Can you give some idea about that?
See, see, mass transfer is all about it's separation processes. So basically, if you have a mixture and if you want to separate some component out of it,
Mhm,
then you have to perform a mass transfer operation. Let's say if you have a mixture of like crude oil is a mixture of so many things: crude oil control, petrol, kerosene,
mhm,
diesel, and all. So we perform
mhm.
distillation. We heat it based on
Okay.
the difference from the so based on the difference in the boiling points of the materials containing in the solution. So at the different stages, different we will get different components. At one stage we'll get
Mhm.
kerosene, one stage we'll get petrol, right? So
Okay.
so all these things will be taught in mass transfer. How the
Mhm.
molecules are diffusing when you apply heat, how the molecules are diffusing.
Okay.
Yeah, so the students have to learn what is equilibrium. So
Mhm.
when the two phases are in a contact, the
Mhm.
components the components in the those phases will rearrange themselves to establish equilibrium.
Okay.
So in the mass transfer, students will learn about how this equilibrium will be achieved and what are the calculations you have to make. What are the
Mhm.
calculations so that you can just get your desired composition.
Mhm.
So the same
Okay.
way in the heat transfer also. So
Mhm.
you have to maintain all these reactors in industry at a constant temperature, right? So the
Mhm.
heat transfer will tell you what how to give heat to the reactor or some materials.
Mhm.
You have to supply heat, and you have to sometimes you have to cool the system. You have to take
Okay.
away the heat. So
Mhm.
so the mass transfer is a principles. It's all about the principles. How you
Mhm.
can transfer energy between the two, components.
Okay.
And the numerical methods is obviously it is a calculation part. So all these mass transfer and heat transfer equations are in terms of differential equations, right? So
Mhm.
to solve them, you have to use numerical methods. So
Mhm. Okay.
these are all interconnected. It's not like
Mhm.
you have to learn only one thing and you
Mhm.
can forget like one student has to learn all the like all are interconnected, and one equipment will use all these things.
Okay, okay, okay.
Yeah.
Understood. Okay. So basically, thank you. So mass transfer and the heat transfer and practical examples also you have given, like from the crude oil, how we are
Mm-hmm.
separating the petrol, diesel, kerosene, depends
Mm-hmm.
on their masses and then how their molecules are interconnected between each other, basically. That is a very good way of explaining the mass and heat transfer. Thank you, SK. So now going ahead, as you have completed your masters from
Yeah.
one of the prestigious university in the India, IIT Guwahati, and you worked on your thesis also. So in terms of writing the thesis, and then you are working on the research papers also right now.
Hmm.
So can you give some details about while writing the thesis, what students should focus upon?
Hmm.
It's really helpful.
So my thesis writing experience is really interesting.
Mm-hmm.
See, I know a lot of students I observe, they basically they Google, they use Grammarly, they use different online tools to produce the
Mhm.
content. But I strongly disagree with that. I strongly disobey that, because students have to uh, develop the skill to write, to produce sentences on their own.
Okay.
Yeah. So my writing experience is, so basically I uh, in like thesis. So basically you have to write introduction, and
Mm.
then you have to write the methodology,
Mhm.
and then after that you have to produce your result, and you
Mm.
have to discuss the results, and then you have to write the conclusion.
Correct.
Yeah. So just look at the each part. If you like, if you come to introduction, you just try to write whatever you feel about the subject. You have to write what type of things that got you to that subject, what type of things that evoked you to learn that subject, and what are the previous literature. So this is very standard process. I think students students should practice writing this on their own.
Mhm.
Hmm. So coming to the methodology, see, it's already there. Like methodology, you should try to write on your own words. Students have to try to write on the own words. It's very easy. Like writing methodology is very easy. And then results. Coming to the results, there is a standard way to produce the results, and you have to draw the conclusions. You just simply compare the previous results and and these results, and you can write the conclusions.
Okay. Okay. Understood.
So
Understood.
this is a proper way. And
Mm.
students, you can just students can by practice, like this is shared by practice.
Mhm.
You have to read some research papers. If you read some research papers, and if you analyze what are they
Mhm.
telling, how they are writing introduction, how they are writing conclusions,
Mhm.
one student will easily get an understanding how to write a thesis. This is a very interesting process and very easy process. All you need is practice. That's it.
Exactly, exactly. That is true. That is true, SK. So now, in terms of this thesis and then the results, kind of, and the methodology, basically. So
Hmm.
for that, in the chemical engineering, then what are the tools and the topics, or like how they can put up the results? They have to do it through the simulations, or they have to go on ground and they have to do, or how exactly it is, basically.
Yeah, there are two types of researches. One is simulation based, and
Mhm.
another one is experimental based.
Okay.
So if you come to the experimental based, people has to do experiments in a reactor. There is a lab scale reactors in the
Mhm.
campus. So people will be doing a lab scale experiments,
Mhm.
and they will be analyzing the output of their experiment.
Mhm.
So
Mhm.
there are different instruments available, like HPLC. Uh,
Okay.
so there are different techniques. So
Mhm.
people will be analyzing the component, output of
Mhm.
the experiment, and they will be
Mhm.
the mostly all those results are in terms of graphs. Like there will be correlations between two variables like that.
Okay. Okay.
So in the methodology part, they will just write all the experimental procedure they have carried on. Since you
Mhm.
since students already have done the experiment, it is very easy to write the methodology, right? Because they have done in the real life.
Okay.
So they will just
Understood.
write step by step procedure of experimental procedure, and then they have to
Mhm.
carry on to the results, and they have to produce all the analysis results
Mhm.
they have got from the equipments that they used, and they have to write the
Mhm.
conclusions. The conclusion part, again, students have to have the understanding of basic theory, so that they have to, because there they discuss about the advantages and disadvantages of that experimental procedure, right?
Correct. Correct. Correct.
Yeah, so there for the
Mhm.
conclusions have their part, they have to have some theoretical knowledge. So if you come to
Okay.
the simulation part, simulation is basically simulating a real life experimental setup in a computer. So you are not really conducting the experiment, you are basically simulating the environment.
Okay. Okay.
So there are different. If you come to the molecular dynamics, you will use some different softwares. If you come to the process control, you will basically we use MATLAB. And
Mhm.
if you come to the transport phenomena, people use HYSYS, and if you come to the industrial setup, people use Aspen. So there are different kind of softwares for the
Mm-hmm.
different fields in the chemical engineering. So
Okay.
the people will choose appropriate software for their simulating their environment, real life experimental environment, and then they
Mm-hmm.
carry on all the calculations in the software,
Mm-hmm.
and the software will give you the results. And sometimes in the process control, if you come to the process control, sometimes we have to design a strategy to control, so we can test the strategy in the MATLAB.
Okay.
So
Understood.
we will test the new strategy, and we will write down all the uh, uh, procedures, how the strategy came to the mind, like how strategy is devised, like how the strategy is formulated. All these formulations we will write in methodology, and as part
Mm-hmm.
of the results produced from the strategies, we will just write them in the results part. And in the conclusion again, you have to have a theoretical knowledge. You have to explain how the strategies improved the results, how the strategy is better than the previous strategies.
Mm-hmm.
So it is more of a mathematics. If a student want to come to the simulations part, if he want to work on the simulating an environment on a computer, he has to deal with a great depth of mathematics, because all the strategies are formulated in the mathematical equations, right?
Correct. Correct.
Yeah. So people have to deal with a great depth of mathematics.
Okay. Okay.
Yeah, that's
Understood.
why I just tell students, always tell students to learn coding, because coding now is entering all the fields.
Okay, okay, understood, understood. Okay, so this is all about the simulation based and the experimental based, basically.
Yeah.
So that is very good information. So student can choose their own domain. According to that,
Yes.
they can work on their thesis, basically.
Yeah.
Okay. So now you have come to your PhD from your master's. So I wanted to understand what was your exact motivation for doing the PhD, and like why you have chosen this path.
Basically, my motivation is I want to become a pioneering engineer in the new
Mm.
technology, because see, the technology is always evolving.
Mhm, mhm, mhm.
Like if you go back to 50 years back, there is one technology. If you come to the late 200 to the 2000, if you come to early 2000s, we have keypad mobiles, and now we have smartphones. So the technology is continuously evolving. So I want to be a part of evolving technology. I just want to
Mhm,
research about the technology that's going to rule the world in the future. So that is my
mhm, mhm.
motivation. So I personally think automation industry is going to rule the world in the future. So,
Oh.
and personally I have very uh, a huge interest in the automation, in the process control from the very young age. So I just tell the students to choose a field which has a strong future impact.
Mhm. Okay, okay.
Yeah.
So the one should have the future scope also, and also their
Yes, yes,
strong
yes.
interest also has to be there.
Yes, yes. If you just go to websites of different universities,
Mhm.
you just go to foreign universities and just if you search for the postdoctoral
Mhm.
positions, they will have
Okay.
different objectives
Uh-huh.
written on the websites. So those objectives are basically the future scope. They have seen some future scope in those objectives. That's why they open the positions for that particular postdoc positions.
Understood,
So a
understood.
student can just by going to which type of positions are opening in the research, a student can understand what
Mhm.
are the type of scope that have for the different kind of fields in the engineering.
Understood, understood, understood. Okay. So basically, while choosing your PhD topic, you first check what are the postdoc research
Yeah, options
facilities are
available.
available and the offerings are there from the
Yeah.
renowned university professors.
Yes.
And then only you will say, okay, this particular domain has a very bright future, and that's why they are offering the postdoc positions.
Yes. Yes. Yes.
And according to that, choose your PhD and see where your interest lies, basically.
Yeah. So not only postdoc, it is one of the way. There are different ways also.
Okay.
You can
Like what?
just you can just track the current publications. What are
Mm.
And if you go to the current working topics of different professors in universities, if you just read
Mm.
what are they currently working on,
Okay.
so there are different ways. If this
Mm-hmm.
is the research part. In
Mm-hmm.
industry, if you come to industry part, if you want to work in an industry,
Mm-hmm.
I just you have to talk to the people who are in the industry, because it is
Mm-hmm.
the things that I talk to a person. I talk to a person
Mm-hmm.
who is working in the Dow Chemicals in America.
Okay.
So she told me that they are currently working on the hybrid models.
Okay.
So hybrid models means analytical. There will be an analytical model. Analytical model means which is modeled in the terms of differential equations, and then there
Mm-hmm.
is an AI model. AI model is basically it's a mathematical model on neural networks. So they are
Mm-hmm.
working on some hybrid model. They want to combine these two models and work on the hybrid model.
Okay.
So
Okay.
then I came to know that okay, the people are still working. This is the progress. These type of things. So you have to have talk to the some professionals in industry.
Mm-hmm.
Then
Okay.
you will really get what's happening in the industry. It is really difficult to get news about these things. What are in the pilot stage in the industries, because they don't give these news outside, right?
Exactly.
Yeah.
Exactly.
So for
Understood.
the research part, you just have to go through the professor's profile, postdoc positions. For the industry part, just talk to some professionals. You can connect them in
Mm-hmm.
the LinkedIn and all that.
Okay.
So just stay updated with the what are the research currently happening in the industry and in the academia, and just
Okay.
choose your future path.
Okay, okay. Understood, understood, SK. Thank you very much, SK, for all this in-depth information. So we are at the last phase of our discussion. So what exactly you wanted to suggest to all the chemical engineers in their undergrad or the masters? If you have any one message you can share.
Uh, I will tell everybody be curious. They should be curious
Mhm.
always.
Okay, okay.
Don't think about results. Don't think about in terms of money, what how much I will get if I do this, how much. No, they will ruin your brain. Just be curious. Just do whatever
Mhm.
you are interested in. Just do
Mhm.
research. Just talk to
Mhm.
people, and
Okay.
always willing to learn something new. Always be excited to learn something new,
Mhm.
because in this era every person should be learning. Like even if you are at the age of 40, you
Mhm.
should still learn some new skill, otherwise you won't survive in the industry.
Uh-huh.
Yeah,
Understood.
so you should always be in the mode of in the learning mode.
Learning more.
Yeah,
Exactly.
so I just tell students to be in always in the learning mode and be curious and do. Just
Mhm.
don't think about in terms of money and materials. Just think about in terms of
Mhm.
knowledge, and
Mhm.
just pursue whatever you want. Just do
Mhm.
research, and yeah.
Mhm. Okay, okay. Understood, understood. Thank you, SK, for your valuable guidance and your time. And thank you.
Yeah, thank you, Suresh.
Yeah, thank you. Have a nice day. Bye.
Have a nice day, Suresh.